Thanks for joining. We are in day number 14, and today we are again going to continue our QoS. It will take some time to complete this QoS because QoS is big topic, and if you see official Cisco QoS book, it having more than 600 pages, I think. It's a big book, guidebook. So yeah, it will take time, but slowly you will understand everything. So far what we have done, that we have tried to understand the classification and marking. Layer 2 classification is COS, class of service, and layer 3 classification and marking is DSCP, differential service code point. They are part of IPv4 header. Within IPv4 header, we have layer 2 and layer 3 classification and marking. Now, how we are doing this classification and marking? We are dividing the traffic between mission critical traffic, high priority traffic, mid priority traffic, and low priority traffic, like that, or critical traffic, audio, video, voice traffic, etc. That you can see here in this spectrum. The spectrum that we have here, you can see clearly on top, starting on top, we have very high priority, low latency traffic, and then business traffic, and then we have bulk and scavenger traffic. Like that, we can divide these traffic in categories and in subcategories. So you have sections and subsections. According to that, you can go and mark it with respect to DSCP bits, right? So these are a standard configuration. These are Cisco suggested configuration. If you go and log into any device, you'll find the configuration like this only that we have. So then we have discussed about the priority queues. So if you see somewhere, and these things you will see again and again and again, let me highlight. So if you see this box 1P3Q3T, that means that you're assigning one priority queue and 3 queue with 3 threshold. That means that in this 3 queue, you have Q1, Q2, Q3. Queue is nothing but how the data, they are handled by the router or switch. Those are router or switch queue. Later on, when we'll go and study the SD-WAN, you'll find then SD-WAN we have the V-edge. And in V-edge also you'll find two form factor. One is virtual and other one will be hardware. Now in virtual and hardware, in virtual, the queue is total 4 queues are there. And in hardware, you will find that there are total 8 queue. So that means that when you will go and divide the traffic for virtual versus hardware in terms of quality of service, so in hardware, in terms of SD-WAN, in hardware you have 8 queue, and in software you have 4 queue. So here you can see that this is one of the example related to 4 queue. It is hardware, but it is 4 queue, example of 4 queue. And then if I go next to any other switch, I'll come back to configuration. I'll come back to this. If I go to any other switch here, suppose 3850 type of switch, let's see the queue design for this. And in these slides, you will see all those queue design and all. I mention here how many queues are there, but we'll check from the. See, this is full-fledged configuration for N bar, 1400 plus app and 12 class model. We'll come to this. Before going there, I just wanted to show you some. So here you can see. Now this is one of the queue example where you will see that we have 2 priority, 6 queue, and in 1 queue you have 3 threshold. So 2 priority is nothing but queue only. That means how many queues you have? This is example with 8 queue, 2 plus 6. In that 8 queue, you have 2 priority queue, right? So here you can see in the diagram that you have priority queue 1, priority queue 2, and then the queue that you have. So queue number 3, queue number 4, Q3, Q4, Q5, Q6, Q7, Q8. Rest 1, 2, 3, 4, 5, 6 queues you have. But in these queues also, you can go and further divide in 3 threshold values. Suppose this is threshold 1, this is threshold 2, this is threshold 3. Right? So this will be the example related to 6Q and 3 threshold. Right? So all the time I'm telling about threshold, and maybe you're unable to understand this. Let me go and quickly draw one diagram. This time you'll understand 100%. So suppose you think that in a queue, how much packet a queue can handle. So according to that, you can go and create the limit. So suppose this is one queue, and in this one queue, I am setting 1, 2, 3 limit. So this is queue versus threshold. Suppose this is threshold, this is T3, this is T1, T2, sorry, and this is T1, right? T1, T2, T3, and these are nothing but the queue. So this is one queue, and within one queue you have 3 spectrum. This is queue, this is parent queue, right? So that means this is Q1 and T1. Then this will become, for example, just for example, I'm giving you this. Anyways, Q1 and Q2, they are the uh, priority queue, so it should start with Q3. So suppose this is example related to Q3, but within Q3 also you have Q3, Q3 T1, you have Q3 T2, and you have Q3 T3, right? Like that you will be having Q4 T1, Q4 T2, Q4 T3, then Q5, Q6, Q7. Now this Q8 that you are seeing in the bottom, no need to divide this in the different priority. It's up to us because this is for default traffic. This is, you can think this as a default queue, right? And like that it is divided. So this is the example related to queue, and later on you will see that you have further, later on you will see that you have more example related to queues as well. So if I go, you can say 2P, 6Q, 3T with weighted threshold queue or something. We'll see that what is WTT, WTD. Some small terms will be there. And let me quickly go and show you some other examples as well. So now you can see that this is Catalyst 6000. Just focus on this part here. 2 priority queue, 6 queues, and 40. So Catalyst, you can further divide one queue in 4 threshold values, right? Then let's go and check the Nexus design. So Nexus design, you will see 4 queue and 1. It has only 4 queue, but in all queue you have only 1 threshold. Continuing like this, you can see Nexus 7700, 1 priority queue, 7 queue, all the 7 queues having 1 threshold, right? So you can see that you have the priority queue. So point here is this, either you have 4 QoS structure or you have 8 QoS structure. right? Mostly because if you are dealing with the good hardware like Catalyst 6000, Catalyst 9000, Nexus 7000, all these good platforms, all this good hardware platform, you have 8 QoS structure. The only
Just a quick one
difference,
though.
yeah,
Just a quick one. So this queue, I'm trying to understand the queue. Are they the colors? This 1, 2, 3, 4, 5, 6, 7.
8,
From the top, there is
yeah.
this one is 8. The COS, you count the COS to it as well. CS0, the white one.
CS0 is the
Because
default queue, queue number 8.
okay, so 0, 1, 2, 3. So how do you now count? It says C7, 6. So
Starting
that's
with 1, 2, 3,
okay.
4,
Mm-hmm.
5, 6, 7, 8.
Okay, I see. Okay.
And these are the policy name. If you log into the Nexus, in Nexus you have QoS policy configured by default. This is the default policy, whole entire policy. This is the policy name. So 8E 4Q 8Q out. Like that's 4Q Q8 out. Like this you have Q and mapping in the Nexus. Right? Now you will understand this more and more. So what I'm telling that you have 8Q structure, right? Mostly you will see 8Q structure. In that 8Q, sometimes you have one priority queue, sometimes you have two priority queue. It depends upon hardware to hardware. So 7700 having this arrangement. And if you go back to Catalyst 6000, you can see we have this arrangement in Catalyst switch. So in Catalyst switch, actually, two queues are there for high priority traffic because maybe that is the network where you have the voice traffic, more voice traffic, because you are using Catalyst switch. In data center switches, you don't have that much voice traffic, so that's why you have only one queue reserved for voice. So priority queue, you can see PQ shape to 30%. This is priority queue where we are mapping costs 5, 6, 7. And if you go and check the DSCP related to that, you can get it easily. So not only the network control and the traffic control, I told you earlier that control related traffic we are putting inside the priority queue, plus VoIP and video we are putting in the priority queue in the Nexus. Then you can see that multimedia conferencing real time, they are going to queue number 2. Then signaling transaction network management data, they are going to, so you can see again in this queue we have two division going to Q3 and some traffic is going to Q2. Rest of the traffic you can see here like this. Maybe this diagram is correct, only taken from Cisco. And finally the scavenger traffic that is going to the bulk, the default queue, right? So like that we have all the arrangement. Once you understand this arrangement, the configuration part is very easy. Let's try to do that as well. So far so good, right? Here it's easy. So you can understand this. So main part that you need to understand is this chart. If you know this chart, 80% of QoS you will understand. Okay. So let's try to understand the configuration. And I told you that different hardware having different QoS configuration style. So when we are talking about 2960, there you have to go and enable the multi-layer switch QoS that is not enabled by default. And then you need to create this configuration called the trust costs model. So then we are doing cost to DSCP marking 0, 8, 16, 20. So see 1, 2, 3, 4, 5, 6, 7, 8. And if you see here, DSCP 0 to cost 0. DSCP 8 will be mapped to cost 111111. Sorry, my bad. So DHCP 8 is 1, 10 is again 1, 12 is, so 8 to 14, they are mapped to 1. Now that's why you can see 8 and then 16 and then 24, then 32, 40 like that. So if you go to this configuration, the marking you can see 0, 8, 16, 24, 32, 46, 48 like that. Whenever we are changing here, 0, leave that 0, 8, 16, 24, 32, 40, 48, right? And 56. So this is the marking here up to 0 to 56, right? Then rest of the configuration, very easy and straightforward. MLS queues trust the DHCP and then trust the boundaries. So if you have the Cisco IP phone, the Cisco TrustSec, IP camera, media player, you can simply do MLS queues trust these devices. Now the yellow color that you are seeing, they are the interface specific configuration. So you have to go to the interfaces and you need to trust those interfaces. For IP phone, we are using 46. So that's why we have this 46 marked here, that the chart we can see. Now, next configuration that you are seeing here is this configuration is related to queue configuration, right? We have the queues as well. And according to queue, this part, if you understand this part, you will understand the QoS CLI configuration. So let's try to understand for next 5 minutes. So now you can see here in this chart that we are dividing the traffic. See, best effort traffic, network management, signaling, mission critical, interactive, voice and routing. Like that, we can go and divide the traffic, right? So let's see the CLI configuration that we have, how we are first of all creating the classes. So when we are creating the classes, you can see that we have the class related to VoIP, multimedia. These are the classes. Then signaling, transaction data, bulk data, escalator. So 1, 2, 3, 4, 5, 6. 6 classes we have, right? What we are doing? So this is a CLI configuration. Class map match all VoIP, match access group, name VoIP, right? So once we have this class, then what we are doing in this class? So then we are going to the policy map. This is single policy map. Later on, we have to go and apply this policy map to the interface. So we'll go to the interface and then we can apply this policy map. Now you can see this policy map. We are calling the class and we are setting the DHCP. So VoIP, we are setting EF, expedite forwarding. Then multimedia, we are setting, you can see within the multimedia, we are setting assured forwarding 41, signaling CS3, class selector 3. Then for transaction, assured forwarding 21, bulk data assured forwarding 11, the scavenger CS1, and then default that is 0. Like that, we are doing the configuration. This is very easy example related to classification and marking related to QoS.
That's a quick question. Do you have a documentation that explains this thing apart from um, just this table?
I have shared the ebook
Well, I don't have it.
in the WhatsApp chat.
Okay.
So you can go and apply this configuration to the interface. Today we'll do that. I'll show you in the CLI. Rest of the configuration. So once you understand that configuration, so either it's 3850 or any switch, any catalyst switch, you can understand the configuration. In Nexus switches, we have little bit difference in the configuration, but here you will understand all this configuration, that how you can go and apply. So enable the trust boundary, and then trust boundary, you can go to the interface and you can trust the device for Cisco phone, CTS, IP camera. Then you should have the class. So you can see here that we have the class related to voice. We are marking the COS 5. If you are marking COS, it's up to you. You're marking the COS or DSCP. Then signaling COS 3. Then IP phone. What we are doing, this is the policy for IP phone. We are calling the class, setting the DSCP, calling the signaling, setting the class selector and default, and then we are applying to the interface. Right. Now we have one very big example, that is actually the configuration related to the QoS. That is a standard configuration related to QoS that you should know and apply to your organization. This is the full configuration. Okay, so let's try to understand this. Now you can see that always first step is what? Step number 1 is that you have to go and create the class. So we are creating the class, and within the class you will see that we are matching the protocol. You can match the access list as well. Not only protocol, but you can match the access list as well. So here you can see Cisco standard practice, this match VoIP. I'll come to that. So step number 1 is matching the class, right? This will be the step number 1. Then step number 2, calling the class within policy, right? So we will see here that we are creating the class, and then we have this policy map called marking. We are calling the classes, and one by one we are setting the DSCP. Now this is not 100% of QoS, because at the moment we are only discussing about classification and marking. What about that you have to set the bandwidth percent? What about you have to set the scheduling, the other mechanism and all? So this is not presented here. This is just the classification and the marking part, right? So, but still you have a step number 2. Steps will be the common. Calling the class within the policy. Once you are calling the class within the policy, then you can go and set the DSCP. You can go and set the policy, policing, buffering, or shaping. You can go and set the shaping is nothing but the buffer only. You can go and do the scheduling, something like the scheduling, and then schedule maybe some. Then you can go and set the drop preference, like it is tail drop or random early detection. Once you have this step number 2, then you can go to step number 3, where you have to go and apply the policy to the interface. Right. So step number 1 and step number 2, they are actually very logical, means there we are building the policy, and step number 3 that you have to go and apply to the egress interface or ingress interface of the WAN interface. Like, you're applying to the WAN interface going out, or maybe you're applying to the LAN interface. Anyway, we'll see that where we'll go and apply this. Up to this point, you are able to understand?
Maybe when I see it live, I will understand.
Okay.
when you do the configuration?
Now we'll do the same thing. I'll go and do that in configuration. It's not like this. We have the device. Let's go and
Yeah, that's what we are saying. The thing is, we teach few topics, then we do the practice, then we see how it works and how everything is flowing, and that's the way we'll be able to catch.
configuration commands you'll get again and again and again. And this is this funda is true related to your lab exam as well. Same things, same thing you have to do for 10 times, but obviously little bit changes are there. Okay, so in Cisco you have repetition if you are working in CLI. So here we are in one of the switch. Let's see the version for this particular switch. What image we have? All of these are fully virtual switches, but all these switches having latest images. Version 15, you can see this is version 15, and this is advanced enterprise. So advanced enterprise, 3 licenses are there, right? Base, one is base license, one is I think enterprise, advanced, like that 3 licenses are there. This is the latest one, although this is virtual image, but in this type of images you can run any type of CLI command. This is L2 image, means you can do all sort of switching command and all sort of QoS configurations and all those things you can do. So now if you go here and go to the class map, and if I type question mark, see match all and match or. All means you can see logical and. The option is and. You know and means that 1 plus 2 plus 3. If all 3 condition will match, then only it will work. But if you are using OR operation, so either 1 or 2 or 3, that means any of them will match, this condition will be valid, right? So if like we are following just this document, so I'll go and use match all. So match all, and then you have to give the name. This is, I am putting this name, voice. So class map, match all, voice. Now once we are inside the C map, you can see now we are in the C map, class map. So here we can go and see, we can match the, so I just wanted to show you that not only you can go and match the protocol, but you can go and match the access group as well. Access group, I think, is nothing, just this is just the access list. You can go and create the access list as well, and you can match it. So before going any further, I'll come back to this. Let's go and create IP access list just to show you a standard. Okay. And then if I go back here, let's see class map here, and then if I can match the access group was one. Oops. Name. So both is taking name-based access list and number-based access list, right? Even I can go and do match the protocol. And maybe in this version, it will not take the, okay. Like that, you can see here in the example, attribute is, oh, attribute is there. This latest image is taking that. Traffic class. VoIP telephony. Then the business class, if it has. So you can see that you have to follow that command sheet that we have. From here, you have to go business relevance, business relevant. So you may have business relevant, business irrelevant. Simply type question mark here. So see, relevant is there, irrelevant is there. So now what we have done, section class, if we go and check the class, so we created one class map called voice. Within that, we are putting the access list as well in name of access group. And then we have the attribute class for VoIP, like that means simply here. So within one class, we are putting different type of protocols, different type of access list, and then we have one class ready. Like that, you can go and create the broadcast. I will not, okay, let me do one thing. Just to save our time. That's why I have given you all these things in the formatable format, means you can copy and paste, right? Simply go here and let's put that here. Somewhere I can see some error. Yeah, the line is, I think when the line is crossing, it is throwing error, but no problem. You can simply check do show run section class. And now you'll see that what classes we have created. Maybe font size is a bit small. So from here, classes, you can see that we have broadcast, bulk data, voice that we have created, scavenger, transactional data, right? So these are the classes. At least 4 or 5 classes we have. Few classes is not created that you can check in your configuration. Maybe network control not got created and few of them. But till this point, you have any doubt? Any doubt you have till this point? Simply creating the class, right? And matching the protocol and access list. Very simple. Okay. And then what you will do, that then you have to create one policy map. So let's exit from here. Create the policy map. Say, for example, this is marking. This is not full-fledged QoS configuration. This is just for marking. We'll see more later on. So what I want to match here, class was, then I want to set the DSCP EF. Likewise, class, you can type exit and then you can do the command. Say broadcast video, and then you can set the DSCP CS5. Then you can go and give the class real time. If it is not there, it will throw the error. So if I type real time in, oops, interactive, the DSCP CS, like that you can go and mark. I'll not go and type everything. Even I have option, I can go and simply copy and paste. So one place it is showing error class bulk data. Okay, so let's see. Maybe that is not defined. So if I go here and type exit, if I type class, you see,
Okay.
once you are typing class, so we are inside policy map. Once you type class, yes, what you're telling? Okay, and then set DSCP AF11. Some copy paste error is there because this is in different format.
Yeah, that's what I was saying. There was an error there. There was an error. That's it.
Yeah, it's just copy paste error problem on that. Let's see. Show run policy map. Now we'll see in the policy marking we have voice, broadcast, real time, multimedia, multimedia streaming, signaling, network control, network management, network transactional data. Then we have bulk data. I don't have this scavenger. Some error was there while doing this class, right? So like that, you can match this. So again, I have to go inside the policy map, marking. Once you are inside policy map, it will show you are in PMAP. Then you can go and add this scavenger. So then you will go inside policy map and see that is the class map. And then you are setting the marking. Now, once you do this, you have to go it and apply to any of the interface in the WAN facing interface. So assuming that E01 is a WAN facing interface, so we can go inside E0/1 and we can apply it. Now, once you apply this policy, you have to use this keyword called service policy. Okay, so if you go and try to type here policy map or something, it will not understand. You have to go and type this service policy, and then it is asking either input or output. Its type is, I think type is some different thing. Type inspect is there for firewall policy, firewall MQS. Okay, so output, what was that name? Marking. And input. So we have applied this to the output and input. Okay, ingress and egress direction to the WAN facing interface, right? You see how easy it was to create the policy and apply the policy. It's very easy, right? The most important thing here is this, to understand the logic. If you understand the logic, doing this configuration, for our CCI exam, we are going to configure maybe 2000 lines of CLI configuration, but if you have good understanding about this, what you want to do, then it's always easy to do the configuration, CLI configuration and all, right? So your task is this, that go through these QoS slides. You have the lab in your evng file also, you can do all these things. What you can't do related to Nexus configuration, but apart from that, you can do most of the things. What I will do in next class, I will add a rest of the configuration. This is just one part. This is just classification and marking. It's not full. We have to go and add the bandwidth logic there, bandwidth percentage. You have to go and add polishing, shaping, all these logics. If you add all these logics, like 30% more if you learn, then your complete QoS part will be covered. Okay, both theoretically and practically as well. And this is one of the best slides you will see anywhere. The slide that you are seeing, this is not, this much descriptive slide is not there anywhere. It will help you to understand the QoS, and still this QoS will not end, because in SD-WAN also I am taking QoS classes, and there also I am configuring the QoS from CLI and GUI as well. Okay, if you have any question, please ask.